Mohit Paul from Cisco Systems. I work with Cisco's wireless engineering test team. In this short video, I'll show you how to configure Cisco's high availability solution on 5500 WLAN controllers. So I'll take you to my controllers here. I have two controllers from my network that I decide to make my primary and secondary controller. So as you can see, this is my controller 1. Here is my controller 2. So let's see which image is this box running. Okay, I see this box is running 73101.0. Which image is here? Okay, this box is also running 73101.0. The reason why I checked the image on both the controllers is because the minimum HA requirement is you need to have same hardware, same software on both the controllers. Then you need to have a minimum 50 AP count license on the secondary controller. So if you look at my secondary here, you will see that I have 250 license because this is my lab device, so I have upgraded it to 250. But the minimum AP count you would need is 50 license to make this box as secondary. There is no license that you need to be installed on the primary, so I don't need any configuration for the licensing on my primary box. Now let's begin with the configuration. As you can see, this box is on 80.5 as its management interface. The other box is on 80.7. Right. So I would like to make a point here that you need to make sure the redundancy management and the peer management interfaces are from the same subnet as the management IP address of your primary controller. But no matter what IP you have on your secondary controller's management interface, once the sync will happen, this IP will get changed to the management IP address of the active controller. So I will make this as as I'm making this as my primary controller. This is going to be my redundancy management IP address. If you have a fresh box, you may not see this redundancy management interface here. We'll go quickly and do the configuration. So, well, I have already made this box as primary unit, so I won't be running the command configure redundancy unit primary on this controller. However, we would need to configure the IP addresses. So, okay, let's begin with this. Show interface address redundancy management. I'll give it as 8.6, and within the same command, I can configure my peer redundancy management interface also, which I'll keep it as 8. So like I said, you need to make sure that redundancy management and peer management interface are on the same subnet as of the primary controller's management interface. Okay? We'll go to the secondary box. As you can see, as I've already shown you, that I have the license count as required. So the minimum count is 50, and it has to be a permanent license. I'll make this box as secondary. Before we do that, let me take a quick look. Which mode is it? Oh, okay. This box was also acting as a primary controller for some other network. Okay. So we'll go and do configure redundancy unit secondary. Now the role should have been changed by now. Okay, yeah, good. That looks good. Right, okay. I see that it has the IP address. Okay. Now I need to run the same command here and configure its IP address. So if you see, it's actually the reverse. Here you are configuring 80.6 as the primary controller's redundancy management interface, whereas 90.8 is the peer controller's redundancy management interface. Right? So, okay. I see it's good. Now, You might have noticed that, when we haven't configured the redundancy management interface, this redundant port was having an IP address 000, right? But if you see it now, it has an IP address of 169.254.80.6. So let me tell you this: from this IP, you need not to configure this. The device picks it automatically with using the first two octets as 169.254, and the other two octets will be taken from your redundancy interface. All right. So I think I think that's all about the configuration. You have it here. We have set the role. This looks good to me. Okay. All right. So we have this box as the secondary. The interfaces are configured on both the boxes. All we need to do is now I'll just make sure that, I can reach my, right, okay, I knew that my port is down on this controller. So I'll just quickly enable it, and we'll try to ping my gateway. Yep, there you go. Okay, that looks good. So I'll do show redundancy mode SSO. Okay, that's a command to enable it. I'll say yes here, and we'll run the same command here also. All right, so once the box will now both the boxes will reboot and negotiate their role, do the role negotiation. So hopefully we should have them as primary and secondary now. Let's see. So ideally we expect the primary controller to take up as active, and the secondary to come up as the standby unit. Oh, by the way, I just forgot to show you, but then just want to tell you that my primary controller had one access point connected, whereas the secondary controller didn't have any AP connected to it before that. So you can see once we have the device hub as active, it should start serving the APs, and that AP's data will also be synced to the standby unit. So right now, both the boxes have their redundancy processes up, and they're just finding the peer. Oh, okay. See how quick that was. So I guess it took hardly 10 seconds or so maximum to find its peer. So it has finally found a peer, and this guy is taking up as standby as its role, and is downloading. It has already downloaded the configuration from the active controller and is now comparing its configuration from the configuration it had on it, in its database. Okay, that's good. So we'll see. Okay, we can see that this guy is inactive, and why it says it's down, the communication, is because this guy is resetting here. Yes, it will do the peer search again because as a process, it has to understand whether there is any peer, because there are chances that the peer may go down. So it will do the peer check again. It will again download the configuration. We'll make sure that, the configuration that the controller downloaded previously, is it exactly the same match with the standby, not from the active or not. Okay, it has done the role negotiation. It has downloaded the configuration and is doing the XML match. Right, one more thing I would like to point out here is that till the time the standby is, up and running, you will not be able to do any configuration on the active box. So as you can see this message, it says the configuration is boxed because standby WLC is still booting up, and you will be notified. So yes, here you can see on this, the startup XMLs are same, so it doesn't require any reboot. And this should, so let's see the states here. Okay, as you can see, the peer state is in standby cold. So It's in standby code because it hasn't come up yet. Okay, I see it just came up. So as you can see, if you may have noticed, the controller's prompt was controller 2 here, and now it's controller 1, same as this, because it has synced the configuration. So here it should say standby hot, and here it should say standby hot also for its local state, which is good. And now if I do AP summary, I do have an AP here. Let me trigger a failover here, and we should see that APs are still joined, which means, oh, okay, as you can see that WLC has switched over in 2 milliseconds, and APs are still there, which is good. So that means our configuration for the high availability is done successfully, and the feature is functioning properly. Thanks for watching.